now that we have our project all set up, let's talk about 3 important and fundamental principles that we need to constantly keep in mind if we want to build good, modern websites or web apps with HTML and CSS. And I call them the 3 pillars of writing good HTML and CSS. Now, this lecture is not exactly about coding, but it's absolutely crucial that we talk about these principles here right in the beginning of the course, so that we start off the project without making any mistakes we would then have to fix later down the road. Alright, so the 3 pillars are responsive design, writing maintainable and scalable code, and caring about web performance. But let's look at them one by one. So, the first principle is responsive design, or responsive web design, which simply means that we build one website that works beautifully across all screen sizes on all devices. But I'm sure you already know that, right? So, responsive design is absolutely a standard today, and so there is no way you're going to build a non-responsive website in 2017 or even later. Now, if you're taking this advanced course, then I assume that you already know at least the fundamentals of responsive web design, things like fluid layouts and media queries. But we're going to take it one step further in this course, because modern responsive design also includes stuff like responsive images, which is a huge topic itself, using correct units for things like font sizes or element dimensions, and it also includes having either a desktop first or a mobile first strategy. And we're going to talk about all of that during the projects of this course. Next up, we need to talk about writing maintainable and scalable code. Now, this is actually more important for you, the developer, than for the final user of the website. But it's still something we need to follow if we want to build a good website. So, writing maintainable and scalable code means to write code that is clean, easy to understand, that supports future growth, and above all, that is reusable for you as well as for other developers who might take on your project in the future. So, if we want to write maintainable and scalable code, we need to care and think about our CSS architecture, which is the way we organize our files, how we name our classes, and how we structure our markup in HTML. Now, don't worry if all of this sounds weird or complicated to you, because it's really not. And we'll talk about this stuff in a separate lecture a bit later in this section. What I want you to understand for now is that this stuff is really important if you want to step up your game and become a more professional CSS or front-end web developer in general. Writing maintainable code is something that all professional web developers care about a lot. Alright, and last but not least, let's talk web performance. Making a website or app more performant means to make it faster and to make it smaller in size, so that the user has to download less data. Now, there are many things that affect performance, and some factors don't have much to do with our code. But some of the things that we can do is to make as little HTTP requests as possible, meaning that we should include as little as possible files in our HTML document, write as little code as possible, of course, compress our code, and use a preprocessor like Sass that we're going to explore later in this course. Now, this is all great, but maybe the biggest impact we can have on performance is to actually reduce the use of images, because images are usually what makes up by far the biggest part of the size of a website. We can do so by using only images that are really necessary for a website or app, and also by compressing these images so that they use less bandwidth for the final user. Okay, so these are the 3 pillars that we will have in mind all the time while building our projects. We have to always ask ourselves if the code we're writing is responsive, if it's maintainable and scalable, and if it affects web performance. Hello and welcome back to a more conceptual lecture this time. And this is probably one of the most important lectures of the entire course. I promise you that we're going to go back to some serious coding after this section, but since you signed up for an advanced CSS course, we need to get into some advanced stuff before moving on in the course and in our project. Now, I couldn't really call this course an advanced CSS course if I wouldn't show you some of the stuff that happens behind the scenes of CSS as we load the web page, right? Now, most, if not all the other courses out there, they just teach you the coding stuff itself. But in my courses, I like to teach you how stuff actually works. and the important concepts that you need to understand in order to become a better web developer, and in this case, a better CSS developer. That's what I did in my JavaScript course if you took that one, and that's what I do in this course as well. So let's take a look now. And we start by asking what actually happens to our CSS code when we load up a certain web page in a browser. Now, a bunch of stuff happens behind the scenes of the internet until a browser can actually start loading that website we requested. Things like HTTP requests, figuring out the right domain name service, etc. We're not going to focus on all of that though. Instead, we're only interested in what happens in the browser on a computer where the user opens the page. So our starting point is when the browser actually starts to load the initial HTML file. It then takes the loaded HTML code and parses it, which basically means that it decodes the code line by line. From this process, the browser builds the so-called document object model, or DOM, which basically describes the entire web document, basically like a family tree, with parents, children, and sibling elements. So this document object model is where the entire decoded HTML code is stored. Now, as the browser parses the HTML, it also finds the style sheets included in the HTML head, and it starts loading them as well. And just like the HTML, CSS is also parsed. But the parsing of CSS is a bit more complex, and that's why we'll talk about that in great detail in the next lecture. For now, let me just tell you that during the CSS parsing phase, there are two main steps. First off, conflicting CSS declarations are resolved through a process known as the cascade. The second step in the CSS parsing is to process final CSS values, like, for instance, converting a margin defined in percentage units to pixels. Imagine that we define a left margin as 50%, but that 50% on a smartphone is completely different than the 50% on a large screen, right? And that's why these percentages and other relative units can only be calculated on the user's device in the parsing phase. But again, we're going to talk more about that over the next lectures. And of course, I'm going to show you all of this in code as well, because that's obviously the whole point of learning all of this. Alright, now after all of this is done, the final CSS is also stored in a tree-like structure called the CSS object model, similar to the DOM. And now that we have the HTML as well as the CSS parsed and stored, these together form the so-called rendered tree. And with that, we finally have everything we need to render the page. Now, in order to actually render the page, the browser uses something called the visual formatting model. This algorithm calculates and uses a bunch of stuff that you already know about, like the box model, floats, and positioning. We're going to talk a little bit about how this visual formatting model works in one of the next lectures, because this actually has a lot to do about how we write our code. So stay tuned for that lecture. Okay, and so finally, after the visual formatting model has done its work, the website is finally rendered or painted to the screen, and the process is finished. Great! So now you understand what happens behind the scenes of a page load in a browser. And over the next couple of lectures, you're going to understand it even better and even deeper. So, I hope that you're curious now, so let's move on to the next lecture right now.